year 10 unit 1, and we're now looking at standard form. So we use standard form to write very large and very small numbers without having to write out all of the digits. For example, the distance of kilometers from the solar system to our nearest star is this number here, and we can write that more easily than as 4.0678 times 10 to the power 13, sometimes in science called scientific notation as well. Standard form has two parts. It is a number between 1 and 10, that's this number here. It can't be equal to 10, so it has to be either in between 1 and 10, but can't be equal to 10, and then multiplied then by a power of 10. So we're going to convert this into standard form. So you've got to work out where you want the decimal place to go to make this number between 1 and 10. Hopefully we can see it's there. So we're going to go 3.47. So that's our number, multiplied by 10. The decimal point is currently here. So the number's been moved down 5 places, I think, so it's 1. So it's currently here, 1, 2, 3, 4, 5. So that means it's times 10 to the power of 5. If we're doing then 2.84 times 10 to the power of 2, quite an easy one, that's 10 to the power of 2, so it's 100, but the 2 means we move the number 2 this way. So that would give us then 284. It's a bit like multiplying 2.84 times 100, because 10 squared is just 100. Smaller numbers then, where am I going to put the decimal point? I'm going to put it here. So again, that's going to be 1, 2, 3, 4. So it's 5.52 times 10. And if I write times 10 to the power of 4, that's going to make it a big number. So for our small numbers, we of course use in a negative. So it's the power of minus 4. Finally then, 8.64 times 10 to the minus 5. So that's going to be a small number, 0.000864. I nearly write the thing out and then check after that I've got it in the right place. So it's currently here. So we're going 1, 2, 3, 4, 5. So that then is what the original ordinary number must have been. Okay, now I want to do a wee bit of calculations then with the two, and these can be quite awkward. So take a look and see. I've changed some of these numbers. I think they're a wee bit hectic, so I've changed it to 3.2 times 10 to the power of 2, and B I've changed it to 8 times 10 to the power of 5. So AB means we need to multiply these two together, so it's 3.2 times 10 to the power of 2 multiplied by 8 times 10 to the power of 5. Hopefully we agree that that's the same as 3.2 times by 8 times by 10 to the power of 2 times by 10 to the power of 5. 3.2 times by 8, if you want you could do it over to here. You could do 32 times 8 and you get 256. You can take my word for it, and then so it's going to be 25.6. 10 to the power 2 times 10 to the power 5 gives me 10 to the power 7. We're almost there. We have a problem here. This is almost looks like standard form, but this number here isn't in standard form, so we need to write it in standard form. So it's a bit like one of the questions in the first example. I'm actually going to cover this over. This sort of tends to confuse people a bit. How do I write 25.6 in standard form? It's 2.56 times 10, and that then is to the power of 1. So this here is the same as this. This is the hard bit. And then that's by 10 to the power of 7. That gives me then 2.56 times 10 to the power of 8. And that's what you get whenever you multiply those out. We're doing this without a calculator, obviously, but you can do it with a calculator and just type the numbers in. Next one then is A over B. So we are doing 3.2 times 10 to the power of 2 divided by 8 times 10 to the power of 5. The way we write that, this is 3.2 divided by 8 multiplied by 10 to the power of 2 divided by 10 to the power of 5. Again, you need to look at that and have a wee think about it, because it is quite tough. We're doing this divided by this. So we divide the number bits, that's here. We divide then the power of 10 bits, that's here. 3.2 divided by 8 gives us 0.4 multiplied by 10 to the power of minus 3. Again, I hope you see where that has come from. 10 to the power of 2 divided by 10 to the power of 5. We subtract our power here as we end up with this. Similar to the last one then, this number here isn't in standard form. So we've got to rewrite it 4 times 10 to the minus 1. That's what this number is. times 10 to the power minus 3, and that gives me 4 times 10 to the power of minus 4. Okay, finally then, they asked us to do is a plus b. It's the most awkward one, but it's nearly the simplest. If you're adding or subtracting numbers in standard form, you simply need to change them into normal numbers, and then add them, and then change it back again. So where a is 3.2 times 10 to the power 2, so it's 320. 8 times 10 to the power 5 is going to be, let me think, goodness, that would be the power 3, the power 5 there, I think, as well, so it's our 8. Sorry, I'm losing my mind here. So we end up then with a number like that. If we add these, we get 8, 0, 0, 3, 2, 0, and changing it back then into standard form, we get 8.0032 times 10 to the power of 1, 2, 3, 4, 5. And we end up then with that number there. That's the two numbers added together. Second example then, and again I've changed it very slightly just because the numbers were a wee bit crazy. So if P is 4 times 10 to the minus 3 and Q is 3.2 times 10 to the power of minus 5, find PQ. So we're going to do 4 times 10 to the minus 3 multiplied by 3.2 times 10 to the power of minus 5. 4 times 3.2, again you could do it over here if you want. 32 times 4 is going to give us 128, so this is going to be 12.8 times 10 to the power of minus 8. Now I've nearly skipped a wee line there, I hope you're okay with that. 4 times 3.2 gives me 12.8. 10 to the power minus 3 times 10 to the power minus 5, I add the two powers and I end up then with minus 8. This number isn't in standard form, I need to write it in standard form. 1.28 times 10 to the power 1 multiplied by 10 to the power minus 8. That gives me 1.28 times 10 to the power of minus 7. The second one then is P divided by Q. So we have 4 times 10 to the power of minus 3 divided by 3.2 times 10 to the power of minus 5. 4 divided by 3.2 multiplied by 10 to the power minus 3 divided by 10 to the power minus 5. 4 divided by 3.2. Again, you can do a couple of different bits and pieces. You can do your calculations over there, but it gives us 4 divided by 3.2. It's going to be 1 1/4. So we have 1.25, which luckily in this case, as you know, is in standard form already. And then this one, 10 to the power minus 3 divided by 10 to the power minus 5. So it's actually minus 3 minus minus 5. So that's times 10 to the power of 2. Remember, you're dividing a small number into a slightly bigger number, so you will have a bigger number. So we end up then with that. Finally, then we need to do P plus Q. So 4 times 10 to the power minus 3 is 0.004. And then this one's 0.000. Is it 0.32? 1, 2, 3, 4, 5. And if we add those together, we get 0.00432. And writing that in standard form, we get 4.032 times 10 to the minus